the objective collapse hypothesis. Have you ever truly looked at the night sky? Not just a glance, but a deep, prolonged gaze, where you feel the immense, silent weight of all that space, all those distant suns? It feels solid, doesn't it? Real, independent of you. A universe that would carry on, majestic and unyielding, whether you were here to see it or not. Now close your eyes. Think of the smallest thing you can imagine, an electron, dancing around the heart of an atom. According to the most successful theory in human history, quantum mechanics, that electron isn't a tiny, solid ball. It's a ghost, a shimmering cloud of potential, a set of probabilities. It exists in a blurred state of maybe here and maybe there, spinning in all directions at once, until you look at it. The very act of measurement, of observation, seems to force it to make a choice, to become real. So which is it? Is the universe out there a solid, objective reality? Or is it a fluid, dreamlike potentiality that only crystallizes when observed? For nearly a century, this has been the central, beautiful schism at the heart of physics. But what if I told you there is a third option? A theory so profound, so elegant, and so strangely mystical that it dares to suggest that reality itself is a continuous act of creation. This is not the Copenhagen Interpretation, and it's not the many worlds theory. This is the objective collapse hypothesis, and it might just be the most important story the universe has ever told us about itself. To understand the sheer magic of this idea, we first have to appreciate the problem it's trying to solve. The quantum world is a realm of pure wizardry. Particles are not things. They are tendencies. They are waves of possibility, described by a mathematical entity called the wave function. This wave function is a recipe of could-bes. An atom could be decayed or not decayed, and until you check, it genuinely exists in a superposition, a state of being both at once. This is not a philosophical metaphor. We've proven it in laboratories. It's how our quantum computers work, leveraging this ghostly simultaneity to perform calculations that would take a classical computer the age of the universe. But then, something happens. When we set up a detector to see which state the atom is in, the magic vanishes. The fuzzy cloud of probability collapses into a single, definite, classical fact. The atom is either decayed or it isn't. The electron is here, not there. The conventional explanation, the so-called Copenhagen Interpretation, says this collapse is caused by us, the observer, the act of measurement. This has led to a century of mind-bending questions. Is consciousness somehow fundamental to the fabric of reality? Does the universe only become real when a mind is there to perceive it? It's a powerful, almost solipsistic idea, but it feels messy, incomplete. Are cats and trees and stars not real until a human looks at them? That seems like a strangely human-centric view of a cosmos that is 13.8 billion years old. Then there's the many worlds interpretation, which offers a breathtaking, if dizzying, alternative. It says the wave function never collapses. Instead, at every quantum decision point, the entire universe splits. In one branch, you see the atom decayed. In another, an alternate version of you sees it intact. Every possibility, no matter how remote, is realized in a near-infinite fractal of parallel realities. It's a compelling vision, a multiverse of endless what-ifs. But it asks us to believe in an unfathomable number of unseen universes, all to preserve the mathematics of the wave function. It solves the problem by making reality infinitely bigger. But what if the truth is simpler and far more beautiful? What if the collapse of the wave function isn't triggered by something as vague as measurement or as extravagant as universe splitting? What if it is a fundamental, objective process woven into the very laws of spacetime. This is the radical proposition of the objective collapse hypothesis. The pioneers of this idea, visionaries like Roger Penrose, asked a simple, profound question. What is the one thing that truly separates the fuzzy quantum world from the sharp, definite classical world we live in? Their answer: gravity. Think about it. In the tiny quantum realm, particles are almost massless. Gravity is irrelevant. They can dance in their superpositions, weightless ghosts in a probabilistic haze. But as objects get larger, more massive, gravity begins to bite. It is the curvature of space-time itself. And according to Penrose, a superposition isn't just a mathematical curiosity. It is a physical state where an object is, in a very real sense, in two slightly different places at once. This means it's creating two slightly different gravitational fields. Penrose proposes that space-time itself cannot tolerate this ambiguity. It's like a stretched rubber sheet that can't decide which way to bend. This state of affairs is inherently unstable. It's a flaw in the fabric of reality. And to resolve this tension, to heal this wound in space-time, the universe does the only thing it can do. It forces a decision. The wave function objectively collapses into one reality or the other. Not because anyone looked, but because the universe demands a single, consistent reality to exist. Let that sink in. Reality, at its most fundamental level, is a series of spontaneous, self-organizing events. The universe is not a static, pre-recorded movie. It is being written, moment by moment, by its own inherent need for consistency. The definite world we see emerges from the quantum fog, not through our observation, but through a cosmic background process of resolution. A universe constantly bringing itself into focus. This is where the magic truly deepens. This hypothesis gives us a potential, and I believe, a glorious answer to the oldest question: why is there something rather than nothing? If the objective collapse hypothesis is true, then existence is not a noun. It is a verb. To be is an active process. The universe is a dynamic, ongoing computation whose output is the solidity of your hands, the rock beneath your feet, the light from a billion-year-old star. The very fact that you are experiencing a coherent, stable world right now is evidence of this continuous, silent, cosmic effort. It re-enchants the cosmos. It means that every moment, at the very edge of perception, reality is flickering. It's dreaming all possibilities before settling on the one we experience. The tree falling in the forest does make a sound, not because a human is there, but because the universe is listening to itself and making a choice. This idea takes us even further into the realm of science fiction made science fact. What is consciousness? Under this model, our brains are not just passive observers. They are incredibly complex systems, vast networks of neurons, constantly approaching the threshold where quantum superpositions become unstable. Our thoughts, our moments of decision, our very awareness could be intimately tied to these objective collapse events. We aren't causing the collapse from the outside, we are participating in it from within. Our consciousness is not the director of the play, but a lead actor, deeply embedded in the stage where the spontaneous creation of reality is happening. It paints a picture of a participatory universe, not in a human-centric way, but in a cosmic one. We are made of the same stuff as stars, and the same process that crystallizes a star's position in the sky is, on a different scale, crystallizing our thoughts and experiences. We are not separate from the universe. We are of it, in the most literal, physical sense imaginable. This is a vision of a living, breathing cosmos, a universe that is not cold and mechanical, but one that possesses a deep, intrinsic creativity. It is a universe that sings itself into existence, one definitive note at a time, resolving its own quantum harmonies into the symphony of the classical world. And this is just the beginning. The journey into understanding the true nature of reality is the greatest adventure we can ever undertake. It forces us to question everything we think we know about time, space, and our own place in the grand scheme. If this journey excites you, if these ideas spark something in you, then I have a request. Please, like this video and subscribe to the channel. It truly helps this community grow and allows us to dive even deeper into these mysteries together. And I want to hear from you. What do you think? Does the idea of a universe that objectively defines itself feel right to you? Or are you drawn to the observer-created reality or the infinite multiverse? Let me know in the comments below. This conversation is what makes this so thrilling. And for those of you who are truly hungry to go further, to explore the edges where physics, philosophy, and mysticism collide, I want to invite you on an even deeper dive. I've written a book that expands on these very ideas, exploring the holographic principle, the nature of consciousness, and a vision of a cosmos that is fundamentally informational and magical. It's called Holographic Multiverse, and the link to get your copy is in the description below. If you enjoyed this exploration, I think you'll find it a mind-expanding read. So the next time you look up at the stars, remember, you are not just looking at distant points of light. You are witnessing the end result of a cosmic process, a universe that from the quantum depths to the galactic heights is in a perpetual state of becoming. A universe willing itself, moment by moment, into the solid, beautiful, and breathtaking reality we are privileged to call home. Thank you for watching. Stay curious.